Hello, today we're going to talk about behavior of waves. All right, the first thing we're going to talk about is reflection. So reflection is the bouncing off of a wave off a boundary between two mediums. The boundary is a border formed by the meeting of two different substances. So an example of this is radar or sonar, like when the cops have the radar gun. What it does is shoot out a wave, it hits, and some of that is reflected back to the gun, which you can read the speed. Same thing with sonar. Some animals use reflection to find food, like bats and dolphins. They shoot out their echolocation, or they shoot out the waves. It reflects off something and it comes back to them, and they can tell where their food is. So here we have an example of reflection. So this is a sound wave hitting a wall. It hits it, comes back, just goes back the other way. This is when it's hitting at 90 degrees. So completely perpendicular. But if it doesn't hit at 90 degrees, you have this other image. So this is what is called an incident ray. And this is the motion. And the ray here shows the direction of motion. So this ray, or this sound, is being directed at something else besides 90 degrees. It hits right there. Where it hits becomes a perpendicular line called normal, let me write it exactly right, normal reference line. This line is perpendicular to the boundary that it hits. So we have our incident ray hitting, and then what happens off of that is our reflection. So this is called our R, or our angle of reflection. Over here, this is our I, or our angle of incidence. All right, these two angles are going to be equal. So if I say my angle of reflection is 35 degrees, what is my I going to be? My I has to be, or my angle of incidence has to be 35 degrees. Refraction is when it's a change of direction because of the change of speed of a wave hitting a new medium. So what I just showed you with reflection, so I had an angle of incidence that hit at my normal line, my normal reference line. So this is my incident ray. Motion's going this way because the ray's pointing where it's going. And I had a reflection over here. So I had my incidence angle and I had my reflection angle because it was, well, it's not a great line, but it's good enough. Because it hit a boundary. It reflected off. But what refraction is it actually goes into the medium. So imagine this is a wall, this is the sound wave. Sound wave hits it and bounces off. Some of that sound actually goes inside and changes direction depending on the medium. This is called our angle of refraction. All right, a good example of this, probably the best example that you always get with science, is looking into water. So when you look into the water and you see a fish, that fish is actually not right there, because what you're doing is your line of sight is going in there and then it's reflecting. All right, so So you're actually seeing it in a different spot than it actually is. That's the big one. So if you like see a rock or a seashell in the water, you put your hand down there and it's not there. That's because of refraction is moving it, so it looks like it's somewhere different than it is. So that's refraction. Once it hits a new medium, it actually changes the angle of it. So whereas these two are equal, so if this one is 60, this one's 60, this is not 60, because it changes its speed based on, or it changes its direction based on the speed when it hits a new medium. All right, the next one we're going to talk about is diffraction. So diffraction is when a wave diffracts, it bends around obstacle or passes through an opening and spreads out. So an example of this is a loud crash in the hallway, or like when your fire alarm goes off at your house. So you have a large crash here. Say this is the hallway. This is the entrance to your room. It's a small opening. So that wave starts going out, and this is just diffraction. I'm not going to do all the reflection and everything crazy like. All right. So when it hits your doorway, it actually bends and starts opening up again. All right, and then it propagates throughout the entire room. What it doesn't do is just go straight ahead. All right. So if this was the case, you could stand right here and not hear a single thing. No, it diffracts, so it propagates and fills up the entire room. That's diffraction. Another one you see is a lot with water going through rocks. So you throw a rock into the water, it hits here, and then it goes through the two little barricades and starts opening up again. So that's diffraction. It's just waves open up when they pass through the opening and propagates into the next room. So there you go. So it starts off big, hits it, then it reopens back up. All right, the last thing we're going to talk about here is interference. So interference is when waves meet, their energies added together. All right. So actually, crazy story, the first time I actually heard about this was when I was watching cartoons in Batman Beyond. And there was a guy, I can't remember his name now, he could actually turn off sound because he just sent out destructive interference. So it would take away all the sound in there. So a constructive interference first. Constructive, I'm not gonna put interference. So this is when crest meets a crest. This is two different waves. So if I have a wave here, and I say my amplitude is 2, and it's going this direction, and then I have another one over here that's the amplitude of 2, and it's going this direction. When they hit, they'll give me a wave with an amplitude of 4. This is called the law of superposition. So crest will become greater than either wave alone. So these were only 2, they hit each other, and it's constructive. If you think of it, construction is building, you build up on waves when they hit each other. Another example would be if I have one over here that has an amplitude of 1 going this direction, and then I have one over here that has an amplitude of 3 going this direction. When these two crests hit, they'll give me a wave that's amplitude of 4. So that's constructive. You're just adding them together, basically. All right, now our last one here is destructive interference. So whereas constructive built up, let's see what the extra definition, crest of one wave meets the trough of another wave. So it results in smaller waves, but if they're the same size, it results in no wave at all. So I'm going to show you that. So if I have a wave going this direction, and we'll say its amplitude is 3, and then I have a trough going this direction, and we'll say its amplitude is 1. when they hit, I will have a wave that has an amplitude of 2 because it shrinks it down. Now if I have a wave that has an amplitude of 2, a crest, and then I have a trough that has an amplitude of 2. When these two hit, I'll have amplitude 0. It results in a straight line. Destructive interference, they destroy each other. So basically they just bring each other, they shrink each other in destructive because they're not the same size, and it's a crest and a trough, so one's up and one's down. When they hit, they'll shrink. All right, this has been behavior of waves. Hope it helped.